All right, so now we're going to switch gears and take a look at exponential decay. A video is labeled a fan favorite. Oh, must have been one of my math videos, right? All right. A video is labeled a fan favorite if it receives at least 1,000 views per day. Amelia posts a video that gets 8,192 views on the first day. The number of views decreases by 25% each day after that. In how many days total will the video stop being a fan favorite? So as long as she's getting 1,000 views every day, it's going to be a fan favorite. So when does that number dip below 1,000 views per day? So let's just take a look at what this exponential decay model looks like. If we remember, now that we're talking decay, we have our initial amount. It's going to be 1 minus our rate, raised to the power of x. So let's define those variables here. X is going to be our time. We are talking days, so we're going to say number of days that our x is representing. The a is the initial amount. In this case, it's going to be the number of views at the start. We can see over here, she posts a video that gets 8,190 views initially. And then what do we have? R is our decay rate. That's going to be a percentage that we'll write as a decimal. So if we just fill this in, we have f of x equals, our a is 8,192 times 1 minus 25% as a decimal is 0.25 raised to the x power. So we'll just clean up that 1 minus 0.25 real quick. We have 8,192 times 0.75 raised to the x power. So here is a model of our exponential decay. So we are given a table of values right here and a graph. And we can see that the views are decreasing. It went from 8,000 down to 6, down to 4, down to 3. And we want to know when that is going to dip below 1,000, after how many days that is. So I'm going to show you how to do that on a graphing calculator pretty quickly, or how you can get the answer pretty quickly using a graphing calculator. So first I'm going to, there we go, move this over here so we can see the graph. Okay, so we are going to graph our two equations into the graphing calculator. So we go to our y equals, we type in our first function, the 8,192. I'm going to type it exactly as I wrote it, times 0.75. Here's my exponent button, raised to the power of x. I'm going to arrow down because I want to see where the intersection is between that exponential model. That's a decay model. See, our b value is between 0 and 1. All right, and then we want to know when, who is this? Amelia is getting less than 1,000 likes per day. So I'm going to type these in. I'm going to hit graph, and nothing happens. So when nothing happens, that just means that our window is off, right? Because our standard window is from -10 to 10. For the x-axis, for the y-axis, it's -10 to 10. That is, that could be anything. Who knows who used the calculator before you if you're using one from the classroom set. So I'm going to go to zoom. This is the first thing I would try. If we arrow down, it doesn't always work, but sometimes it does. This zoom fit option will take your window and it will fit it to the function that you have typed in. So I'm just going to go ahead and hit enter and let's see. Okay, well, now I can see a little bit more. Now I'm going to look at the window and I can see, all right, we're still at -10 to 10. Maybe I will change, because x is our number of days, so maybe I'll change that to 0 days, and then maybe I'll change this to, I don't know, 15 days? I don't really know what it's going to be. but we want the y. Remember, we're looking for that 1,000 line. So maybe I'll leave it at 4. Maybe I'll just put it from 500 to 1,500. I think that was just at 14,000, which was just, we didn't need it that big. All right, so now let's graph and see. Okay, so that looks a little bit better. So we want to know, here's our number of days, the x is along the bottom, how long does it take for our function to get below, here's 1,000 right here. So I'm going to hit trace, and it tells me what function I am on. If I go left and right, I am tracing along the exponential model. I actually want to trace along the y equals 1,000. I think it just is a little bit more accurate. So if I arrow up, it switches me to the other line, and now I can just trace along here. So I'm going to get that cursor as close to where it seems to be intersecting as I can. I think that looks pretty good. So after 7.27 days, her number of likes is below 1,000. So we will interpret that and answer the question, is it below 7? Is it after 7 days or 8 days? Well, it takes a little bit more than 7 days for her likes to get below 1,000. So we will say after 8 days, because after 8 days, here, I'll keep going over. After 8 days, this is where our function would be right here. She's definitely below 1,000 likes.
Okay, so move that out of our way. Okay, so follow-up question, let's just change it a little bit. Suppose the number of views decreases by 20% per day. And how many days will the number of views per day be less than 1,000? All right, so this does change our exponential model a bit. It's still going to be our initial amount of views, which is 8,192. But now we're increasing by 20%. Before it was 25%. So it's a little bit slower decrease. It'll take more days for her to have less than 1,000 views. Raise to the x power. Okay, let's go ahead and simplify that. So we have f of x equals 8,192 times 0.80 to the x power. Okay, I'm going to add something in because I forgot to do it in the last example. I was just busy with the graphing calculator. When they're asking when the number of views will be less than 1,000, that is our f of x value. That's this. So essentially, what we're doing is we're putting in a 1,000, and this is what we're asking. When is our decay model equal to 1,000? So then what we did is we graphed this as one function, and we graphed that as the second function. That's what we did up above, and we're doing the same thing down below, or right here. And then where they hit each other, that's when they are equal to each other. That's called an intersection, and that's what we were identifying on the graph. So let's use the graphing calculator one more time to quickly get this answer.
Okay, so our follow-up question is similar, but now her views are increasing a little bit slower, just 20% per day. So here's the graphing calculator from answering the first question. I'm going to use this to help answer the question again. I'm going to go back to y equals. We need to change this. We already wrote out what our new function would be. That should be a 0.80. So I'm just going to arrow over and make that an 8 and a 0. That's the only thing I have to change there. That function looks good. We still want to know how long will it take for her, how many days will it be for a number of likes to dip below 1,000. So let's graph on the last window that we had and see if we can see that intersection. Oh, we can again. So we want to trace it. I think when you hit trace, it puts you on whatever your first function was automatically. If you hit left and right, it'll go along that function, but the horizontal line is easier to trace along. So I'm going to arrow up. That puts us on the horizontal line. Let's go on over until we want to estimate. This is all an estimate, or an estimation. Do you think that's the intersection, or do you think that's the intersection. I feel like it's that right there. So now we're seeing that after 9.4 days, that's when her number of likes is 1,000. So as we have more days, as we increase our number of days, that's when it will dip below. So we would say right around after 10 days, we'll just use, we won't do a decimal. After 10 days, she will have less than 1,000 likes.
So then our final answer, which we didn't write on the last example, you could write it, and I think we said it. After 10 days, because we just rounded that, right? Because after 9, it's after 9.4 days, so we're just going to round up. After 10 days, she will have less than, well, this is sloppy, less than 1,000 likes per day.